Hello students, in this video we are going to discuss how to draw probability histogram. So I have considered the same example in which we have considered 4 patients and the probability of success, that is the patient may be cured, is given as 0.8, and we have constructed the probability distribution using binomial formula as you can see on the rear screen. So for all values of x, their their probabilities are provided. Now what we do, we draw a vertical axis on which we have to consider probabilities, and then we will consider a horizontal axis or draw the horizontal axis with a pause, so that we can start drawing the histogram from the very first value. So let's suppose our first value is 0, that is over here. So you know that the histogram is a kind of a bar chart that should have no spaces. So the central value we have taken for this bar as 0. Then the central value should be taken as 1 for the next bar. Then central value should be taken as 2. Then next value should be taken as 3. Then the next central value should be taken as 4. This is how we scale the values of x on the horizontal axis. Now we have the maximum probability of 0.4096. So what we can do, we can take this as 0.05, then this as 0.10, then this as 0.15, then this as 0.20, then this as 0.25, then 0.30, then 0.35, then 0.40, and then 0.45. Now 0.0016. So 0.0016 is a very small probability, maybe ending up somewhere here. So 0 has this, or the bar of 0 has this much height. Now 0.02 may be ending here in terms of its height. Then 0.1536, so that's 0.15336 approximately will be ending up over here. Okay, then we have the next value as 0.4096, so approximately 0.41 it is ending at. And since the next bar has the same height, so we'll draw the next bar with the same height. And this is the line of division between the two consecutive values of x equals 3 and x equals 4. So this is how we can draw the probability histogram for a given data. Over here you can take notice of the shape, about the shape of this distribution. It is a negatively skewed distribution. So what we understand and know, for this we can go to the next slide. Over here we are given three examples to understand the shape of the binomial distribution, how binomial distribution changes its shape dep- depends upon the probability, mainly probability of success. So over here in this example, n has the value 6 that they have taken, and they have considered three different probabilities. Over here, we have just seen that if the probability is zero point 0.8, then we observe binomial distribution to be negatively skewed distribution. So over here you can see that when we have taken or we are given the probability of success as zero point 0.5 and we draw the histogram for n equals to 6, this is how it behaves. So it is clearly a positively skewed distribution that you can see. We can fit over here on this. If p has a value 0 0.5, or probability of success is given as 0 0.5, so this is a symmetrical shape that we can observe. And as p approaches 1, from symmetrical it will start approaching the shape of negatively skewed distribution. So what we understand on the basis of these three examples for the three given probabilities, if p is a small, let's take it as p as a value 0.05. So what we expect a extremely positively skewed distribution we expect. Then at 0.25 we expect this behavior. So it is extremely positively skewed distribution. Then it starts approaching symmetry and reaches the shape of attains the shape of perfect symmetry at p equals zero point 0.5, and then it starts changing its shape to negatively skewed. And if p has a value 0.95, then it is extremely negatively skewed. Then the binomial distribution would take. So this is how binomial distribution changes its shape. And binomial distribution is also used or can also be used as or normal distribution, sorry, can also be used as the approximation to binomial distribution, and it gives us perfect probabilities in case when we are given probability of success and probability of failure equal to each other, that is zero point 0.5 each. Since binomial distribution is following the shape of symmetric perfect symmetry or looking like a bell-shaped curve, if we superimpose a curve on this histogram in which probabilities are given as zero point 0.5, so we can see that it is following a bell-shaped curve. And since normal distribution also follow the bell-shaped curve, so in that case, when we try to approximate probabilities of binomial distribution, specifically when n is very large, then instead of using binomial distribution to estimate probabilities, we can use normal distribution, transforming the binomial parameters to normal parameters. So as far as binomial parameters are concerned, the parameters of binomial distribution are n and p that decides about the shape of the binomial distribution. So binomial has parameters n and p, whereas normal distribution that we already discussed and we'll discuss in the future sessions in detail. So normal distribution has parameters, mean, and variance or standard deviation. So mu, sigma square or sigma. This we call location parameter of normal distribution, while this we call the shape parameter or scale parameter of the normal distribution, because it tells us about the shape of the distribution, scale of dispersion. So mean we call the location, and sigma square or sigma we call the scale parameters. That's all for this session.